My name is Kevin Peeries with Exfo. Today I'll be talking about cleaning connectors using an OTDR. And so, obviously that sounds kind of funny, but really what it is, and I've talked about this in some of my longer seminars, so I really wanted to create a shorter video on this. So when I was a technician and I worked in an operations center, one of the biggest issues that we had was dribbling errors. So these are errors that slowly dribble in, bit errors, into your system. And more often than not, it was a dirty connector, probably 80+% of the time. So I would get out my power meter, so I'd get out my standard power meter, which, I have one here somewhere, and I would check light levels at the receiver, right? So I'd plug it in, check light levels at the receiver, and it would give me a power value in dBm. That's my light levels. And it would say, hey, I have neg 15 dBm of light. That's typically good light for most systems, and it should work. So I don't have a power issue. I probably have a noise issue, which is what reflection creates, especially in an amplified network. And so I start cleaning multiple connectors. I clean the connectors, going into the receive card. I clean the first tie cable, possibly second or, third tie cables. I've worked in a lot of different locations and been to a lot of different locations where there might be 4, 5, 6+ connectors even before you hit the pavement. And so, using a power meter will not tell you if there's any reflection or optical return loss. It just tells you a power value or attenuation, right? So that's the standard function of a power meter. But an OTDR will tell you reflection. And so that's how we're going to use an OTDR to help identify problem connectors and how we use it to validate whether or not we've resolved that reflection issue at that location. So let me go ahead and jump right into it like I usually like to do. So I'm going to go ahead and switch over to, actually I'm going to switch over to a whiteboard. So let me do that real quick here. So I apologize. Let me put myself up in the top right over here where I belong. And then I'm going to switch over to my whiteboard. So my OTDR is blocking my screen over there. So this is my whiteboard here. And so I want to talk a little bit about connectors, what causes reflection, just really quick. I know it's a refresher for those of you that have done some of my former training or have looked at my other videos, but this is really important to emphasize this case. So reflection happens every time there's a change in material type. And so a change in material type meaning, going from fiber over to air, because at some level within this connection, you're going to have an air gap, right? You're going to have an air gap at this connection, and then going back over to fiber. So the change in material type or index of refraction. So we go from index of refraction of about 1.47 or something like that to nearly 0, or I'm sorry, like nearly 1. So whatever the index of refraction for air is, back over to fiber. I should look that up, but it's just over 1. So that's the speed of light within the material. So anytime there's a change in material type, we're going to have reflection, and on OTDR, that's going to be that big spike, right? Or hopefully it's not too big of a spike. And so that's what we're talking about when we're looking at reflection and what causes it. And so typical reflection, we have different values. For a UPC connection, it's a flat cleave. So our reflection is between neg 50 to neg 55. Usually it's closer to neg 55 if it's really good. If it's APC connectors have that 8-degree cleave here. So the reflection is a little bit better. I've done videos on why that is. We expect, usually upwards in the neg 65 or better, right? And so every 3 dB, we take a 50% performance hit or gain. So there's a significant difference between 55 and 65. So neg 65 is better. This is less reflection. And that's what we want, which means, less light coming back towards your transmitter, less noise being in your system, improved ORL, improve bit error rate testing, all of that kind of stuff. So how do we troubleshoot this, right? And so I'm going to show you the network that I have. So I basically just plugged in a bunch of launch cables into my home network. So this is a quick OTDR shot that I did of this network. And what we have here is at each one of these different locations, so here's my OTDR in the launch. And then here's one connector, here's 2 connectors, here's a couple more here, and there's 2 more here. There's something else here, 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 and then of course we have the end, right? So this is essentially my network. It's a combination of some splices, but mostly connectors. because I want to troubleshoot connectors. So I have a lot of connectors here. So I'm running about 4,000 meters or 4 kilometers. We can, whether it's 4,000 meters or 4,000 feet, let's just assume that all these connectors are inside of some sort of a structure or hut. They could all be within the same building, or they can be on different floors, tie cables, whatever. It could be pass-through sites. These are different locations with connectors. And so that's essentially what we have here. So I have about 150 meter fiber here, which is my launch. So my launch, let's get a better color here that we can see. So essentially my launch here is about 150 meters, right? That's the length of my launch. Then I have about a 20 meter separation here with a jumper. Then I have, well, I want to say this is, I'll have to look, but I want to say this is at least 1 kilometer or so in that range. And then another, 20, and I believe this one is like 30 meters, whatever it happens to be, right? So we have, I guess the point is we have multiple connectors and splices across this network here. So it's very important to understand your network, what it looks like, how many tie cables to expect within the building, how many connectors to expect on the span, and where those connectors are at within your site, which is critically important. So we're going to assume that this right here is all one site. We'll just assume this is all one site right here inside, the large data center, a large head-end, MITSO, whatever, right? So we'll just call this the 4 walls, So we're launching from here, and then this is the outside FTP, essentially here, right? So this is our site, and this is what we're going to troubleshoot here today. So I'm going to go ahead and just do a quick OTDR shot. I have a, I do a whole session on OTDRs, so I'm not gonna get into the setups and too much. But here's what we're gonna do. So I shot a quick trace. If I'm troubleshooting connectors, or if I'm troubleshooting at all, what I want to do is I want to use longer durations and shorter pulse width. So I want my durations here to be fairly, long. I mean short rather. All right, sorry, the duration's rather long, and my pulse width as short as I can possibly get it, and still get a nice clean trace. So as I increase my duration, I can decrease my pulse width. Is essentially what I'm looking to do. And so typically I like to shoot about 45 seconds. In this example, I'll just do 30 for the sake of time, and I'm only going to do 1550. 1310 is important, for macro bend testing and those types of things, especially if you're working in a panel, cleaning connectors and those types of things. But in this case, I'm really just showing you how to do reflection. And so if it was a macro bend problem, that would be something different. And so in this case, I'm just going to shoot 1550 for 30 seconds. And so I'm going to say, I'm going to do 30 seconds, and I'm going to hit auto. So we auto based on duration. So the OTDR is going to set the best pulse width that it thinks it can use within 30 seconds. I'm going to go ahead and start that, and then it's going to give us our results. All right, so we'll wait 30 seconds here and get the results, and then we can start analyzing that. And once it's done, I can reduce my pulse width even a little bit more if I want to get better resolution. The shorter the pulse width, the closer the connectors can be. So I can keep dropping that pulse width down to start seeing more and more connectors that are close. And if I can get away with it in 30 seconds without introducing too much noise on the trace, then great. Otherwise, I would have to increase my duration there, right? I have to increase my duration. And let me go ahead and put my head in the bottom right. I really need to pay more attention to that because I was covering some of that stuff up there. And so here's my trace. And I'm pretty happy with it because it shows me everything. So how do I troubleshoot my connectors? Well, here's my patch panel right here. So I have my launch right here, and then I have the patch panel, and then 20 meters away I have another jumper. And so we see that here, right? We have the patch panel. My loss right now is 0.39, so basically 0.4, and my reflection is negative 57.8, which is excellent for a UPC. So this first connector here is UPC. This second one here is APC. So I expect about a negative 55, so I'm doing a little bit better than that. So I have a really good connection here. In fact, to kind of show you what I've done here with this network, to kind of show you what I've done, let me do a quick drop-down camera here. So let me switch my camera here to kind of give you a better idea of what I'm talking about. So let me go to the drop down camera. Whoops. Having all kinds of logistical issues here. Oh, there we go. So my drop down camera, let's switch to that. And so this is what I'm looking at right here, right? So I have the OTDR tray still up. So this right here is 150 meters away from my OTDR port. This is essentially, in this demonstration, my FTP panel. You know, my first panel, could be tie cable panel, whatever. And then 20 meters away, I have, you know, somewhere I have an APC connection. Right, but I want to troubleshoot this one because it's right here in my hands. This is that neg 57.8. Well, heck, that's a good reflection. I don't have to worry about it. If I zoom through here, you know, the table, all my connections are pretty good actually. You know, I cleaned them pretty well. But let's dirty this thing up a little bit. So let's dirty it up a little bit on both sides. You know, rub it on my nose. Try to pick up some contamination. Hopefully without damaging it too much. In fact, if we look at it with the inspection probe tip here, so I'm going to switch, you know, over to the inspection probe. And go ahead and plug that in real quick to give you an idea of what this looks like. So here we go, I'll plug that in. Let me switch to something a little bit larger here. And the resolution is a little bit better than this because, you know, I'm going through VNC and Wi-Fi, it's a little bit different. Now, if there's a lot of stuff on here, auto centering is a little challenge, right? Because it's trying to find the center through all of these globs. But I just kind of wanted to show you what it looked like. It's pretty contaminated. And then, of course, I'm going to go ahead and take this connection here, and then I am going to terminate it real quick. And I'm going to retest, see what it looks like. Heck, I might have made it better, who knows, right? So let me switch back to my VNC view here. So let me do that again, sorry about that. So back to VNC, and let me switch back to my drop-down camera here, sorry. So there we go, drop-down camera. Having a lot of logistical issues today. so I'm going to go ahead and switch back to the OTDR. And let's just reshoot this at the same settings. We'll start the averaging, and then we'll run through it. And then we'll give it 30 seconds, see what it looks like. And you notice it already quickly. You see this big tall spike here? This really big tall spike? That, my friends, is reflection. The taller the spike, the worse the reflection. Now, obviously, I put on some pretty decent contamination here to do that. But this is how you troubleshoot. So, in fact, I'm just going to stop it here. And so if you look at event number 1 now, it's probably going to be merged. It's probably going to be merged now because of so much reflection. Neg 27.5. Neg 27.5 will bring your optical return loss for the entire span down tremendously. In fact, the ORL that we have for this particular span is 26.5, which at 10 gigs with amplification will take errors. Most companies want between 27 and 32. We're failing our ORL from this one connection, this one connector. So if I'm working in a site and I'm taking errors on my system, I can either use an OTDR or IOLM. Anytime I say OTDR, IOLM is also another great troubleshooting feature tool too. But in this case here, I'm talking about the OTDR. But you can essentially, if you have an in-service OTDR, you can test while there's still light on the fiber. So just disconnect from the receive card, plug it in, test through your site, and now you know which connector is giving us the most noise, right? So you see the most noise. In fact, it's showing a little bit of a gainer here, which is interesting. But so there's probably a little bit of a core offset there. And so if we go through here, it's the only one that's giving us any high reflection that contributes to this system's performance. So what do? Well, of course, we're going to get in here, and we're going to clean this connection real quick. So I'm going to go ahead and pop this off. And I like to do a wet to dry cleaning. So I like to do a wet to dry cleaning. So this is not a course on actual cleaning itself. What I like to do is I use a dry tissue, and I wet just a little portion of that tissue, start in the wet, and then pull into the dry. Start in the wet, hold it for a second, and then pull into the dry. Now I'm going to go ahead and put this one in this particular housing here. So I'm done with this one. Then I'm going to go over here, but this other area, I'm going to start in the wet, pull into the dry, start in the wet, pull into the dry. Oops, that one wasn't very good. And then I'm going to go ahead and terminate this other side here. So I've just cleaned my connections. Of course, I would inspect it, right? I would inspect it before I terminate. In fact, let's do that. Let's inspect it real quick. Let's see if we've done a better job, especially since I've already terminated it. So if I didn't inspect it before I terminated it, what's it going to look like? So if there's any contamination on there, you're going to see some like a circling effect, like a halo effect. And look at that, I picked something up. All right, I picked up a little bit of something here. And so what happened there, right? And so in fact, I actually bumped my little thing there. I shouldn't have done that. But obviously I picked up some sort of a lint. So I'm just going to wipe it off real quick and then see what it looks like after that. So let me put that back in and put the bulkhead on there right this time. There we go. Look at that. There's something that's pretty good on there. So when I terminated it, I probably compressed that, right? So it's interesting. Let's see what the other side looks like. I didn't mean for the video for this, to be this long, but I think this is important. So let's look at the other side here. And let it do its thing here. So it looks quite a bit better. Right, it looks quite a bit better. So let's try one more time, and I have a green pass on here, so I'm looking pretty good on this side. So I'll leave this alone. So let's go ahead and see, we'll give this a little bit more of an aggressive clean. So I'm going to hold it into the wet area a little bit longer, and then pull into the dry. Hold the wet area a little bit longer, and then pull into the dry. So let's see how that works. I'm going to grab a different bulkhead here so I don't have to take that one out. So that's a good trick to use a bulkhead, right? I've talked about that during some of my trainings. So I'm going to go ahead and plug it into here, and then we'll see what this does. Look at that, a lot better. There's something off to the side there, so I can change my field of view just to see if maybe I push the lint off if I wanted to. But in this case here, I'm pretty happy with what I see. I got a good pass. I'm going to pop this off and then terminate it right away, right there. So now I've terminated. I make sure I didn't induce any macro bends. We'll see a green pass there. Let's go ahead and see what our OTDR tells us here. Go back to VNC. I've done this a couple times today. So going back to my OTDR, and VNC is lagging a little bit, of course. I'm going to go ahead and retest it again. Let's see if we've improved it from neg 27.5. So we'll run a quick test. And we can see it's very much improved. In fact, it's better than the APC connector next to it. Look at that. As far as the reflection peak there. In fact, I'm going to stop it now just so we don't, because I have enough information to get me what I want. So I'm going to go and stop it. I'm going to click on it. I'm going to zoom into it over here. And then there we go. Neg 61. That's a really, really good UPC connector there. The loss is, 0.4, which is within the half a dB that I'm shooting for, half a dB or less. Typical is about a 0.2. But now I've done that. If I look at my ORL now, my ORL is now 38, almost 39 dB, which is tremendously good. Tremendously good. If you're doing analog video or fiber to the home, they usually want 32 dB of ORL. If you're doing OC192, 27 dB. Most companies are sitting between, like I said, 27 and 32. So, find out which spec you're looking at. And if you look at this here, now we're in great shape. So if you're using systems with Raman amplification, with any sort of amplification at all, these front-end connectors are critically important to troubleshoot, right? So right now, the only connector, the highest reflection connector we have is the one way out here, and it's really not even that bad. It's really good, actually. It is possible to do this in real time as well. So if I go over here to event number 1, I did a video called using 4-point markers to measure events in real time. So I'll put a link into that video so you can watch it. But essentially, I'm going to go ahead and just do that real quick. And I'm gonna do a real-time test at this one location. And what I'm gonna do is I'm gonna increase the pulse width just a little bit to clean it up a little bit. And then I'm gonna stop it, and I'm gonna do a quick averaging at this setting at 30 nanoseconds. So let me do a quick test here. Perfect. I got what I needed. So I'm gonna go back to that same event. Zoom into it, and then go to and so if I highlight, this is my patch panel here. This is the one that's at the end of my launch cable. Here's the second connector next to it. This is the one that was giving us high reflection before. So if I highlight it, click this button over here to zoom, and then go to the measure tab up top, it'll set my markers for me. Then I go to, and I might have to bump one of these markers out, but I'm going to switch to real time. You see right now it's neg 60.3. And then 0.33 here. So I'm going to shoot it in real time, and it's going to measure this for me. And you notice it's very close to where we were at before. Like I said, I might have to bump this out a little bit. And so it's a little noisy, But you see the reflection is really on point. So now I can disconnect this, dirty it, plug it back in, and then get my reflection and what my reflection is doing in real time. And so if it was dirty, so let's say I had like some contamination there and it looked kind of like this, I would take it apart, I would clean it real quick, and I'm not doing a good cleaning here. This is just to speed up the video. I would inspect and clean it, plug it in real quick, and I get instant, validation that I have a pretty good connection. So it's sitting about neg 56.3, somewhere about, between neg 3.7 and neg 4 in that range for loss. I can stop this now. I can go back in here and just retest it, back at the 10 nanoseconds to see what it looks like. So that way, I'm not cleaning it, plugging it in, testing, unplugging it, cleaning it, plugging it in, testing, going back and forth, where instead, I can get that quick validation, and then I can shoot the test real quick and then go back in here and say, okay, I got pretty good results here. And I'm pretty happy with this. Neg 55 and about almost a 0.3 on my loss. So so that's kind of how I how I do a lot of these things. And so that's basically using an OTDR. And again, you can do the Xylem as well to help you identify which connectors to clean. My name is Kevin Peters with Exfo. Thank you very much.